So don't ever let it be said that I cannot absolutely flog a particular subject to absolute death. Right, so some further thoughts on the issue with the Seadoo and potentially the fuel pump issue. Still unconfirmed, still waiting for the parts. So right away, boys, this is not conclusion of the issue. It is only further thoughts on the issue. If that's not your cup of tea, you're welcome to go watch something else. And I don't mean that cheeky. I understand that this is not going to be for everybody. But right, so let's take a look at this waveform in a wee bit more detail again. In discussing it with Dave Sturl, you guys know Dave, you've heard me talk about him before. He posed the question in the comments when I mentioned that I think the pump is, the speed is increasing. And you can see the commutator segments here, which are obviously the time between the segments is synonymous with the speed of the pump. As you can see, our drop off on the pump right about here actually, that the segments actually get closer together and more erratic. To me, because this is the current, again, this is voltage and current, boys, because the current has dropped off and the segments have got closer, that's to me synonymous with the pump being unloaded and speeding up. I hope that makes some sense if you know a thing or two about a waveform interpretation with respect to current waveforms on a fuel pump. So Dave said, why did I think it was being unloaded? And my suspicion was there's maybe an issue with the impeller. The pump element itself is maybe at some point failing. You know, it's maybe flexing, or perhaps it's potentially cracked or damaged in some way, shape, or form. The housing deforms at a certain temperature. Just a theory. But I wasn't really happy with that, to be quite honest, because although that I suppose all of that is possible, I think it's a stretch in my own mind to think that that's happening. And I could not rationalize why the waveform gets so erratic. If you notice, it's quite uniform. I'm not talking about just the period between the segments and the commutator, but the actual uniformity of the waveform is running very steady at a certain speed. And then not only does the speed get erratic, but apparently the load on it gets erratic as well. You can see it's all over the place. Let me go one frame further. You can see it's really a mess. There's no longer the uniformity to the waveform, right? So Denny, formerly the Logical Canuck, but from I think his new channel, I think he's retitled his channel Gadgets Playlist, if I'm not mistaken. I'll correct that in the description if I'm mistaken there. Sorry, Denny. But he said he was mentioning the speed change. He's very good at interpreting the waveforms as well, and a really sharp dude, as you guys likely know. He says, well, the speed picks up, but can't explain the how erratic the waveform is. He says he offered no explanation to that, and at that point in time, I could offer no explanation either. But in thinking it a wee bit more, I think potentially there is an explanation for why this is so erratic. And I think it's not the pump element itself that's actually failing. Let me go back to the one more frame. Sorry, I'm into the normal operation there, boys, and this is where it first fails here. What I think is actually happening here is the pump. There's not an outlet. There's not an issue with the outlet of the pump. It's the inlet of the pump that's the issue. I think the pump here is potentially cavitating. So what's cavitation? What are we talking about here? Everybody thinks of pump outlet pressure, right? You know, when you're thinking of pump operation, and this runs at a really high pressure. Actually, it runs at I think it's 105 psi is the spec pressure. Operating pressure, and prime pressure is I think 30 or 32, 35 psi, something like that. And So for a pump to operate normally, you obviously have to have unrestricted inlet flow and unrestricted outlet flow. Well, no unrestricted outlet flow, but managed outlet flow, let's say, in order to generate pressure. If there was no restriction, there'd be no pressure, obviously. But managed outlet restriction, i.e. the direct injection system that this has. It's not only injected, it's direct injection. So it's a pretty advanced machine for a 20-year ago build. Right, so back to the cavitation issue. So can you appreciate that just like your vacuum cleaner, if you block the inlet hose, and that happens all the time obviously because of the nature of the machine, you can hear the speed of the vacuum will actually climb considerably, right, if the inlet is blocked, because you're unloading it from an air standpoint in the case of a vacuum cleaner. Because its impeller is unloaded, the speed will go up and the current will go down. Kind of counterintuitive, but that's what actually happens. You hear it go up, people think, well, the speed goes up, it's synonymous with the current increase. No, none of it's being unloaded. So in a similar vein, what I think's happening with this fuel pump is potentially the inlet actually has a restriction. Now let me show you, let me cut to the this is the manual, and again this is a Seadoo, okay, so kind of similar to an airplane. This thing can be in all kinds of unusual attitudes when the operator is running through waves, and you've seen them submarine, and these things are pretty, I won't use the word aerobatic, but acrobatic in their operation. So you can appreciate that here's the fuel pump assembly. You can see the pump proper down inside the canister here. This is of course all housed within the fuel tank. And the idea is pretty much regardless of the attitude of the machine, that there will always be a reservoir within the tank for the pump to actually draw on. That makes sense? I think that makes sense. You can see here, and this is the direct injection model drawing, so the applicable drawing. Not shown on here is any kind of sock or pre-filter. You can see on the drawing here, see item 16 there, boys. That's the pressure line to the fuel rail. That's the exterior fuel filter, just a canister, a couple of Jubilee clips. First thing we did was remove that and jump out the circuit. It made no difference, right? So you think, oh well, it's not a fuel filter issue. And our other thought was potentially, was the fuel contaminated because this is a machine that works in a marine environment. Water contamination and the fuel tank was an issue. So my neighbor actually emptied the fuel tank, cleaned it, and replaced the fuel just in case that was an issue. That wasn't the issue. Okay, so back to my point here. What about the inlet of the filter? Again, there is no sock. I asked him, when you looked at it, is there a filter on the inside of the tank? He said no, there's no sock, there's no nothing. But without opening this can, okay, you can't see in the drawing, but if you dig deeper in this manual, let me cut to the drawing here where I think there may well be a filter within this canister. So here's a statement in the manual. There's the pump itself. You can see, boys, again, you can't see anything external, but if you read this statement here, it says fuel filter. A mesh filter is located at the bottom of the fuel pump module inside the fuel tank. An inline fuel filter is also installed on the fuel line going to the fuel rail. That's the canister one that I spoke of. But in this canister, according to this statement, there is in fact a filter inside the canister. So I think I can show you that on one more drawing, just a second. Okay, so this is just kind of a block diagram of the system operation here, boys, and you can see here on the far right of the drawing, fuel delivery. We have the fuel tank itself. It says fuel filter, fuel pump, fuel regulator. So you'll notice that before the pump, it mentions filter, right? So you kind of have to read between the lines in this manual here, but I suspect there is in fact a filter at the inlet side of the pump. So let me just take you back to the waveform for a second, back to the discussion on cavitation. So right here, imagine that if the filter is clogged, and this is just a hypothetical scenario, boys, and the last thing you want to do is actually have a confirmation bias where you start making your theory fit the defect. I've been guilty of that in the past, and perhaps I'm even doing it right now. Time will tell. Can you imagine if the vehicle sits for a period of time, if the inlet filter, that's what I'm going to call the pre-filter. I might use the terms interchangeably. Let's call it pre-filter. Actually, probably that means pre-pump is what I'm referring to. If the pre-filter is severely clogged, if the vehicle sits stationary for a period of time, if it's severely clogged, can you appreciate if there's a long enough period of time, there will be some permeability on the filter, so the fuel will make its way into the can that houses the pump. So when you start the vehicle, you get this operation until the can starts running dry. And then what happens? Then we get into a cavitation scenario here where you're going to have the pump unloading. So you'll have an increase in speed, but you'll also have erratic operation, because what is actual cavitation? Cavitation is really, and this is just a simplified definition, boys, because I'm a simple guy. Where the pressure is going to be so low that you're going to go below the boiling point of the fuel itself. Now that's a wee bit hard to wrap your head around. That, what do you mean the fuel is boiling? It's, you know, it's only an ambient temperature. The outside is 25 degrees or whatever it is. Yes, it is 25 degrees at atmospheric pressure and at atmospheric pressure. But if you drop the atmospheric pressure, that is to say you're on the inlet side of the pump right here, then the boiling point will plummet. So potentially what I think is happening is the fuel is actually boiling, right? It's instead of the pump trying to pump, the pump element, the impeller, trying to pump liquid fuel, potentially if the fuel is actually going into if the pump is actually going into cavitation and the fuel is partially boiling, what it's doing is pumping gaseous fuel, which would unload the pump and potentially account for this completely erratic waveform. Now, I hope that makes some sense, boys. I could be talking complete shit here. I could be talking absolute nonsense. But it kind of makes some sense. Question one, what is unloading the pump? Could it be cavitating? Would that unload the pump and cause erratic operation? Definitely. And what's causing the erratic waveform? Could it be cavitation? Yeah, I kind of think that makes some sense as well. So that answers both very good questions, and has taken me, what is it, 24, 48 hours later to roll over in my head what could be accounting for this. So I know this has been a slow burn of a video, boys, and I'm sure 95% of the people are already gone. But I won't soon forget this waveform. In fact, I'll keep it on my file. But it's not just the what's happening, it's why it's happening. So we have the new fuel pump on order. But if my theory is correct, perhaps we don't even need it. Perhaps the issue is actually just the pre-filter, the filter element at the base of the can itself. But this is just theory, right? This is just discussion. Probably, I don't want to call it far too academic for some people, because that sounds like I'm trying to inflate my own intellect, which is the last thing I'm trying to do here. I'm just trying to publish a video that gets a bit deeper into the situation, boys, because I like that style of thing. I don't want to know just the what, I want to know the why, and maybe that offers some explanation. Time will tell. That's it, boys. Cheers.